Okay, hello and welcome back. So in the last video, we talked about determinants. Today, we are going to apply those. Now there's plenty applications of determinants in many fields, such as in physics, we use them to calculate torques in 3D, also known as moments. But today we're going to talk about Cramer's rule. So what Cramer's rule allows us to do is solve a matrix, an augmented matrix, in the form of this, where we have, of course, this is an augmented matrix, right? We call this section A, and we call this section B. So, how are we going to use determinants to solve this? Well, it's really quite simple. I think what we should do is hop into an example, and so that's really the easiest way to explain how it works. So our example goes as shown. Four, two, five, Z, 7, 1. And this all equals 3, 4, 2. So you may notice, or maybe you haven't yet, but this is not a 2. This is a Z or a Z, depending on where you live. And so how would we solve this, this matrix? Well, we could use Gauss-Jordan elimination to solve for Z and give everything in terms of Z that we have to and whatnot, but you're going to get a really messy matrix. So what we can do is we can say that x1 is the determinant of A with B replacing column 1, I believe. Yeah. Divided by the determinant of A. And it goes on, x2 is the determinant of A with B replacing column 2, and x3 column 3, so on and so forth. You could do this for any size matrix. Now, what makes this so powerful is we can give a situation. Say in this example, we say we want x1 to equal 5. So what's the value of Z for x1 to equal 5? Well, this is actually quite easy using Cramer's rule. So let's get our two matrices. So I'm going to move this 5 up here. Let's figure out what A with B replacing column 1 is. That would be, we're bringing this over here, so we have 3, 4, 2, 4, 2, 5, Z, 7, 1. And our regular A is, of course, this. So what we're going to take is the determinant of this divided by the determinant of this, 3, 4, Z, 1, 2, 7, 0, 5, 1. And we're going to set that equal to 5. Now what you're going to find when you do all of the algebra that you need to find the determinant, if you forget how to do a determinant, I'm not going to go over it in this video to attempt to not drag it on. But in the last video, we figured out it's just 3 times 2, 3, and then a bracket, 2 times 1 minus 7 times 5, 4, and you keep going. So what you're going to get is negative 59 plus 16Z divided by negative 103 and plus 5Z equals 5. And all you have to do is solve for Z. So you're going to times this over to this side, get your Z's over to one side, get your constants over to the other side, divide by the coefficient in front of the Z. And finally, what you're going to get is that Z equals 152 divided by 3. Not a beautiful number, but that is what we get if we want x1 to equal 5. And that's all Cramer's rule is. We could also ask what is the value of z for, say, x1 to be greater than 5, or less than 5, or greater than or equal to 5, or really anything. But I think that's quite intuitive. You might need to know a bit about graphs sometimes for that, and discontinuities, since you have a fraction here. Say if you only had z on the bottom and you were greater than or equal to, you have situations where that might not be so easy to solve, but we're not covering that in this video. So thanks for watching. In the next episode, we are going to talk about the inverse of a matrix, which is really great, really powerful tool for things we will be doing later on in this course. So thanks for watching.